Thanks for the invitation to give me a chance to present our research from NTNU in this workshop. And my name is Houxiang Zhang, and actually after I can introduce myself very simply. And after finish my PhD on mechatronics, and from 2004 to 2010, I worked as a postdoc and then as a docent in University Hamburg in computer science department. And in 2011, I finished my habilitation in Hamburg University, Germany, on informatics. Then after that, I moved to work as a professor on cybernetic mechatronics in NTNU from 2011, actually. In this talk, I will mainly introduce two issues. Actually, one is our research work on digitalization and like a digital ship and digital twin ship. And then in this project, we use open simulation platform as a fundamental infrastructure. So I will introduce that part also. Then after I will also give several case study to see our research work so far, what's the achievement. Then in the end, I will just give a very short summary to see our ongoing activity just right now, and also our future work. NTU is one university in 3 cities, and our main campus in Torheim, and we also have another 2 campuses in Gjøvik and Ålesund. Our campus, actually, we have our own feature. We are very close with industry. Actually, if you see this picture, that is our campus, and the cross street, that is Norwegian Maritime Research Center. Inside, that is Kongsberg, Sintef, also a lot of different companies sitting inside. So we have a daily cooperation with them. So that's the reason. Today, what I introduced, like a digital twinship or open simulation platform, that's not a pure research. Actually, that is a close cooperation with industry. Why we are doing something like that? Actually, from 2012, we began to do the single along modular simulation. That's very classic. And after that, we move one step forward, working on virtual prototyping. And then from 2018, actually, we began to work until today. We are working on digitalization and like a digital twinship. We also have another project like a digital open sea lab. I will introduce it in the end of my talk. Now from this year, 2021, actually now we are working on ship autonomy and the remote control center. Probably the colleagues, you probably know it. And until we are leading ship intelligence and ship autonomy with several companies, with many companies in Norway, and we have 8 years long-term project on ship intelligence ship. And of the red color, that's a project number. That's a different project supported by Norwegian Foundation, by industry. Actually, we are working continuously on it. What is twinship? Actually, we want to develop an open standardized digital twin as a marine industry infrastructure for development, operation, lifecycle service. And this project, as a peer, I'm leading it. And the proposal, we got funding from Norwegian Foundation from 2018. This year, in the end of this year, we'll finish it. We should finish it. The idea is we want to use Cosimulation as a fundamental structure and to make a twin ship in our professional simulator. Then the digital twin can be used for different phases. For example, in the design process, then we can see, okay, everything working together as a whole piece, whether it's can meet of the requirements from the industry or not. So rather than make a mistake too late. And then in the manufacturing phase, we can do the optimization, system single along simulation or identification to see what is situation. And then after that, after the ship is finished, we can deliver it to the user. Then we can use our Twinship as a service to give the support to the service, to the operation training and something like that. Of course, and then we have the remote control center. Then in this way, we receive the operation data, the sensor data, and everything. We can use it for the operation maintenance and the service. So that's the whole idea of it. The project, actually, we are as NTU, we are leading it, and the project we have the main cooperator from industry, like including Kongsberg, DNVGL, and the SINTEF, also Ålesund industry incubator. In parallel, we also have a GIP, like a joint industry project, leading by DNVGL. And in this project, actually, we are mainly on this GIP project. We mainly focus on the open simulation platform, only this package. Then the project leading by DNVGL as a leader, and NTU, Kongsberg, and SINTEF is a main contributor. You can see of the other partners as from industry, they are the under user of our open simulation platform. So now this OSP system is online, everyone can use it. In our Twinship project, as I mentioned, the first key issue is open simulation platform, and then based on that, we will develop a lot of enabling tools for the Twinship, as for earlier warning, prediction, of control optimization, and in the end of this project, we will make a lot of demos and to see and how the Twinship can give support to the industry partners. I will go through it briefly. Why we make Cosimulation, open simulation platform as a fundamental? We know for ship is a comprehensive system, and we have a different system. We have a power system, we have a control system, we have a proportional system, we have a hydrodynamic system, actual. Every single system, actually, they can work very well, in their own standalone simulation software or tools to make everything detailed verification or testing. However, when you put everything together as a whole piece, the proportional system, the propellers, power supply, and with hydrodynamics of the ship, and how could put everything automatically works? Actually, it doesn't. So it doesn't work at all. It doesn't work at all. So that's the reason, that is our motivation. We want to propose to make some fundamental structure, and of the company, as long as you provide your module, you just plug in, then we can run as a whole system. That's the idea. Okay, this picture actually we made it in 2017 actually, and we want to make this Cosimulation as a fundamental. We have provide a core, we have provided some infrastructure, then from different partners, for example, from DNVGL, Kongsberg, Rolls-Royce, and the NTU, and the SINTEF, and everyone, you just have your own module, and the plugin can be directly used. And then we also can propose different tools and app for different service. After that, we can make this service for on one step forward to support ship intelligence. Therefore, in the Cosimulation part, we will work on the following 4 issues. That is how to build these Cosimulation mechanisms. Then how could we define the data infrastructure? Third, how could we define the model and the submodels for Cosimulation and the digital twins? Actually, this part we built reference models, and if you go to Open OSP webpage, you can see it. We have one library of reference models. Everyone can download it. Then in the end, we have to benchmark and to see how the open simulation platform works. And that is how it works. Actually, in the central part, we utilize the FMI interface as a common communication interface. That is a functional mockup interface. And this one, based on Open Modelica, FMI support co-simulation and model exchange, and mainly in our project we use co-simulation mechanisms for details, and it will take a lot of time. So, but I can give example later on to introduce it in this way. So different companies, for example, like Kongsberg, and if they provide the power supply module, like our NTNU, we propose, control module, and the Syntec propose hydrodynamic module. But it doesn't matter you are using which software, using vSim or 20Sim or Simulation X or Simulink, or like us, we use Java or whatever. Then you're just following the structure and package it. Then not only your model will be packaged, mathematical model will be packaged inside. Also, your surrounding environment will be packaged. Therefore, everything we connected to the FMI interface, then, and the different modules, they just have a handshake mechanisms. They just share the input and output. And our NTU, we develop, in order to do it, we develop a lot of tools, supporting tools. How could you package rather the modules? And you can find the information later if you are interested. Based on that, and we are making enabling tools. And for example, we have the real ship. Our NTU will have the real testing ship. Then we have the digital twin ship in simulator. Then everything goes through the remote control center. For example, operation data and sensor data, and also according to the operation conditions, the weather, environmental issues, wave and wind, and everything will also human in the loop control, like human command, will be collected in the remote control center. Then to give support, directly give input, test everything on digital ship. And of the result, we can give the onboard support to the real ship operation. If you actually now we have many different PhD and researchers working on data transmission and the data security, data sensitivity analysis, including the purification, classification, correlation, and the knowledge presentation, and feature detection. After that, of the information will be provided to earlier warning prediction and performance optimization, and also for the human loop control. Then during the operation of the sensor data, operation data, I mean, we'll go back to the remote control center. We have a backup functions to make support, like diagnosis, prognosis. This part actually, we have a lot of result. I can show you as a case. Now the Twinship is running. We already set up onboard data transmission system, and the data through some mechanisms. Actually, we have 2 channels to transform the data back to our remote control center in our co-simulation system. Then, of course, as I mentioned, we have to take care of data security issues, and we have data storage, and then we can make online support. I will introduce case studies. And actually, we already make all the following case studies, but according to time reason, I don't think I will go through everything. I just gave several examples. But I want to mention it. All of the example we already tested in our co-simulation, open simulation platform. This one, we make a digital twins, and as I mentioned, so we just built the ship in simulator, and can present what's the physical ship in the operation. In order to do that, actually our team, we propose FMU proxy, FMU for Java, FMU for C++, and also different tools. That means the company, if you don't have enough knowledge to support this standardization, no problem. You just use our FMU proxy. You can use Java or different language. You build your own model, but then you package it. Then we can directly use it, and you also can protect your IP from industry. And it's just like a black box. We don't know it. You just define your input and output. Then we can just follow your definition like that. For example, the ship maneuvering model, and we have the model vessel model from Syntec Ocean. Then we have a proportional and a thruster model from Kongsberg. And then we have some control module from NTU. Also, we have some observer from NTNU. The different module connected in this way physically. We just connect it in this way. Then after that, you can see it's running. For example, the blue color is the real ship operation in the sea, in the open sea. The red color is the Twinship based on the Cosimulation in our simulator. They are quite similar. Of course, there are some difference. You will see the difference very soon. From the speed and the course, the performance is quite okay, and we are happy with it. But come to the power consumption, if you can see the power consumption, our digital twinship, the power consumption is higher than the real power consumption in the real ship operation. The reason is easy, is understandable, because the model we get it from industry partner, actually the fidelity is not very high, because for some IP reasons, they give us some simplified module. We don't know what is inside, so we just use it. So that's the reason we have some difference, but it's acceptable. I show you one real example, and we make a docking in Ålesund harbor, and here's the ship, and the captain just control the ship for docking in the real situation. Then we are basing on this kind of a Cosimulation. We have a hydrodynamic, proportional, and also the real measurement data means the captain data, the captain command, and also environmental issues, including wind and the waves, will be directly packaged as measured data, to our Cosimulation, to data twins. I can show you the result, and that is the result. And this red color is the real trajectory, and the blue color and the blue ship is the Twinship. And we just make this real-time video and also make a comparison in our simulator, present it in parallelly. So somehow it works okay, but power consumption still with some difference. So the Twinship is running. Then, of course, we also have onboard crane, and the deck machinery is also similar, and the performance is quite okay. But I would like to show a little bit of this diagnosis and prognosis, because we have engines, we have different components, and we also propose AI-based technology to make this failure detection and diagnosis, prognosis issues. Actually, this PhD student, he last summer he finished work. Now he built a company, and in Norway, now he provides this technology for several ship owners, and he make a contract with 20 ships now. I can show you one demo of it, and I'm not so sure you can listen to it or not, because maybe I forgot. But everything already stored. We can, I can just wait. It's our test ship from it. Uh, we built like the
Professor Zhang, I think we cannot hear your voice due to the video running here.
Yeah, you can't hear it, right?
But I think we have understood most of the message on the diagnostics here also. So we cannot hear your voice. We cannot hear your voice either when the video is running.
Okay. But that's okay. Yes. And that is all related to the related publications we published in this Twinship project. I want to show a little bit of our ongoing, and not future, that's our ongoing remote control center project now. And we built our remote control center, and of the data accumulated in our remote control center, and we can give onboard support, as I mentioned at the beginning. So you can see this demo will be it's quite short. I think it's okay. We are also doing, as I mentioned, that for digitalization, I just use one page more to introduce, to finish my talk. The digital chip is the first step. We are now working on digital seed lab. We set up this kind of setup in our outside of Ålesund, between Ålesund and Molde and Trondheim and until Forsmark. So we are building different sensor technology and monitoring to make a digital sea open lab. And we get support from Norwegian Foundation, also from industry. And when we finish, everything will be like that. And so far, we are doing something. We are installing different sensor monitoring and buoyancy and everything, and also wave radar cameras. And in our region, that is Ålesund here, and everything we are working on it. So soon, the Twinship will be part of digital open sea space lab. Okay, thank you for your attention. Yeah.